A woman with horizontal velocity v1 jumps off a dock into a stationary boat. After landing in the boat, the woman and the boat move with velocity v2. Compared to velocity v1, velocity v2 has, and then we have a list of options relating to the magnitude and direction. So really, to solve this problem, all we need to know is the law of conservation of momentum, which tells us that the system momentum before any given event must be equal to the system momentum after that event, provided that the system remains closed. So initially, the only system momentum comes from the woman. So her momentum is her mass, the mass of the woman times her velocity, which we're told is v1. And then afterwards, the woman and the boat are stuck together, essentially. The woman's in the boat. So they will have a combined mass with one shared velocity. So we'll have the mass of the woman plus the mass of the boat times their shared velocity, v2. Now, if we compare v1 and v2, so let's say that we solve for v2, we'll end up with v2 equals the mass of the woman times velocity 1 divided by the mass of the woman plus the mass of the boat. And now looking at this expression, we can see that v2 must be less than v1. So if in the denominator here we only had the mass of the woman and no mass of the boat, then we could cancel the mass of the woman and v2 would be equal to v1. But in this case, we're actually dividing by a number that is bigger than the mass of the woman. It's the mass of the woman plus the mass of the boat. So if we divide by a larger number here, then this entire expression on the right-hand side must be less than v1. So v2, the velocity after the woman and the boat are coupled, must have a smaller magnitude, but it will have the same direction. Another intuitive way to think about this is that if momentum is the product of mass and velocity, and the mass goes up, since we have to take into consideration the mass of the woman and the mass of the boat, then the velocity must go down in order to hold momentum constant. So because the mass is greater after the two are coupled, the velocity must decrease proportionally in order to hold momentum constant. In any case, the correct answer here is that velocity 2 has a smaller magnitude and the same direction.